Hello and welcome back. This is video number 2 in the vintage computer build. So this is the case that I'm going to use for the build. It looks very haggard, and that's because I bought this case I think about 23 years ago. This was my primary computer case, and pretty sure this and the 345 megabyte hard drive were both purchased with money I earned working for a computer repair place. So this is your sort of typical AT full tower case from that period of time. There are, I think, what, 6? 1, 2, 3, 4, 5. So yeah, there are 6 full height, or excuse me, 6 full height, half height, 5¼ inch drive bays, and there's 2 3½ inch external drive bays, and then inside there are additional 3 half height hard drive bays that are only accessible from in there. And this whole assembly with the drives slides out with just one screw, so boom. That's kind of convenient. That was carried over into later models. So another thing that is a little bit more innovative about this case is that 4 screws removes the whole mounting platen for the motherboard. And I don't think in the entire time I had it, when I was building the computer, that even dawned on me, because I remember fighting with these. It's a little bit non-conventional because it used plastic standoffs that stuck in the motherboard, and then you just slide them into place, and there's one screw that held it there. So this can come off to actually install it, but since we're putting such a tiny motherboard in there, it's only going to use this area right here, and we're not going to need any more access than that because it's completely open. And you will note there's 2 power supplies. That was a custom hack of mine. So here's the original factory power supply, and this is the one that I added to it. And the reason that I added that is because this sound card right here had some noise immunity issues. I found that when I had the sound card plugged into speakers and I was accessing the hard drive, it was not the same one but a later one, there was noise from the hard drive that was making it into the sound card. So my idea was, well, I'll power the computer off of this power supply, and I'll power the hard drive off this power supply. And that's what I did, and I honestly don't recall if that improved performance or noise any significant amount. But anyway, this is installed, and the funny thing is I remember when I put this together, I wired it up according to, well, I wired it up the way it was labeled right here, and I remember that it would blow a fuse if I plugged in both power cords at the same time. And what that means is that the line and neutral reverse. So I recently took this power supply apart and looked at the inside, and this sticker right here does not match even in the slightest the wiring on the inside. So the in is supposed to be black and white, and that's actually the out. And the out is supposed to be brown and blue, and those are actually the in. And the brown and blue are actually reversed. So the funny thing is that if you used this power supply and you plugged it in here and you chained it through to a monitor right here, this monitor would not operate correctly if it was wired with the ground and, or at the line and neutral the way it's supposed to be. So I corrected this, and then I I just changed the labeling on here and then added my own label. So anyway, one of the interesting features of old computers is that they had these little knockouts in the back so you could stick your ports. And the reason why you would do that is, so you've got 8 slots for cards right here, and if you had a motherboard with 8 slots and you didn't want to waste one of these backplane slots with this, which is what came with the multi-IO cards, you could unscrew these and then put them in here on the back of the computer and then just run your cables over, and it was as good as that. This computer case has lived multiple iterations. I've got another computer that's in storage that I may build up as a future series that's a 486 DX4 120 VESA local bus and all that stuff. That was in this case at one point. So we're going to try to just kind of detangle some of this stuff, separate some of the wires out, and we can kind of get down to business. One of the sort of amusing things about these old computers has to do with this front panel display right here and the turbo button. So the original IBM PC ran at 4.77 megahertz, and there was another chip made by NEC called the NEC V20, and that would run at 8 or 10 megahertz depending on the variant. Later Turbo XTs ran at 10 megahertz, earlier ones were 8 megahertz. And Intel even made an 8086 chip that ran at 8 megahertz. So in order for some software, games is a good example, to operate in what you would consider a normal fashion, the computer would have to be slowed down. Now, this turbo button right here, you would think, hey, when you press the turbo button, the computer runs faster. Well, that's actually the backwards way. When you connect the turbo pins on the motherboard, it makes the computer run slower. So in the case of this 40 megahertz 386, I would bet that when you connect the turbo button, it actually makes it run at 25 megahertz instead of 40, because some software, you know, like Compaq made the 386-25 as the standard 386, and this might have been too fast for some software that was written for a 25. So anyway, so on top of this turbo button being sort of a misnomer, there is also this little display right here that would light up green and tell you the speed of your computer. And when you press the turbo button, it would go like 66, and when you do that, it'd say 33. Actually, what this is this is just hardwired. You take this thing out, and then you set some jumpers and tell it what speed you're, you know, what turbo speed you are and what non-turbo speed you are. And when you press the button on and off, it just switches between two sets of predetermined switches. So we'll get that working as well. When I powered this up, I didn't see anything light up on this, so there's probably something I need to hook up inside there that wasn't hooked up. This is your main power switch. AT computers have a real power switch. They didn't start doing soft power until ATX came out in the late 90s, where the power switch is just a push button and the computer is live all the time. This physically disconnects the power from the computer. So when the computer is turned off, you're not going to suffer from any, you know, lightning strikes or anything like that, because this physically disconnects the, well, you could get something across that, and the power supply is supposed to charge it. But anyway, this is a measure of, you know, over voltage protection, etc. So, and then, yeah, there's the keyboard lock switch right here, which I don't have the key for, because anybody that ever had a keyboard lock knows that every single key is the same, except for the original IBM PCAT. So anyway, all this does is it locks the keyboard when you turn it one way or the other, and they're all the same key. So we're not going to use that. Oh, this right here this is a little bit later vintage, but it was in the case. This is a quad speed, so 4 times speed. One speed CD-ROMs are 150 kilobytes a second, so this is 600 kilobytes a second. And to give you some measure of idea, let's see, your average computer today, the slow, you know, a computer built with slow components will have a hard drive access of, say, 60 megabytes a second, maybe as low as 40 on an old laptop, but this is only 600 kilobytes a second. So it's pretty slow. You're going to spend a while waiting for stuff to load, but back in the day when you had CD-ROM games, they were only designed for double-speed CD-ROMs, so this being a quad speed was woo! So let's get this all cleared out here, figure out what we're dealing with. This is power, and then we've got another power connection, and this looks like it goes to the front panel to provide juice. So I really don't want to take that front panel out. Let's see here. Let's take the drive cage out and see what we get. building these old computers was a lot more involved than today, because today it's pretty much just, you know, slap a motherboard in the case and plug a bunch of stuff in and you're good to go. These old computers, that is not how it worked. Okay, so that's the keyboard connector, and that is snipped off because I used it for something else. And this is the power. Oh, that's fan power, isn't it? Okay, so then this is probably the power to the front switch. I don't know, we've got backed up priorities here, or backwards priorities. We're worried about the power switch, or the front panel LEDs. Oh, okay. Yeah, so red and, yeah, okay. So that says 5 volts and ground. I'm betting that is the way it's supposed to be connected. Oh, I'm dying to see this little light turn on. Okay, let's see. Hey, 20 megahertz? 40 megahertz. So this is actually already set up for this motherboard. 20 and 40 are the two speeds, but you can see there's something just tremendously amusing about that. Okay, now I think what we'll do is I'll put this drive cage back in there. We need a floppy drive cable before we can do that. And here we go. This is what being a hoarder is all about. A floppy disk cable designed for drive 1 with sufficient length. And we got the little notch taken out of there. That makes life a little easier. Make sure our pins are lined up. And we're home. Let's see here. Side. Now, one of the things I learned growing up that perhaps was not conveyed to everybody else, or maybe it's a contradictory result or information, is that, let's see, is that better? Yeah, that's better. So I like to work on computers with the power supply plugged in. I live in a fairly dry area because, well, I'm in a dry area and static electricity is a problem these days, right now specifically. And so by keeping the computer plugged in, the chassis is grounded, and therefore my body is at ground potential, and I do not have the opportunity to build up static electricity and thus zap any of the components. I think that's all we're going to get. So, now we've got the motherboard installed. That was pretty painless. So, let's install the power cables. Now, something to remember about AT, if you'll never encounter this again, but both of these say P9. These two, there's two connectors, and they're labeled P8 and P9, as in porcupine 8, porcupine 9. And they can be installed either way. There's no keying to prevent them from being installed improperly, but what you should remember is just the black wires go to the middle. And if you remember that, you'll be safe. So, the ATX connector is infinitely more simple to deal with. I think that's going to get ripped off. So now, let's see. Let's plug the power in for a floppy drive. So, let's see about putting this in. Now you can see where things go to cattywampus with this motherboard. So we got our hard drive in. There's a hard drive LED. There we go. So, let's review. We have VGA card down here, Hercules. That's not gonna stay in there. So, VGA Hercules sound card with SCSI controller, network card, and multi-IO controller. And we've got this little backplane adapter that's for a different application, but we'll use the serial port on it. So we have a complete computer. Let's plug it in and see what happens. Okay, so I've repositioned the computer so I repositioned the camera so that you can see both displays when I power it up. Hopefully, things will go as planned. Let me just do another double check and make sure I haven't done anything stupid. Not seeing anything out of place. Let's see. I wonder if that turbo is going to be working. Okay, we got a raster, and it's booting up. Let's get you over here a little bit more. Now I want to run you through that boot cycle again. Reset. See the color? I think that's cool. That was one of their trademark things. And well, that's peculiar with the Hercules. Or if it's just not initialized. Because that one bit stuck high like that for the whole screen, that indicates there's something wrong. Oh. Huh. I touched the ASIC on here, and all of a sudden the lines went away. So I'm wondering, okay, so what we'll do is we'll reseat this chip. We'll do it this way. Okay, that's fixed. Or at least it's behaving like it should. Okay, let's see here. Oh, BIOS mismatch. There we go. Give you better lighting. F1 to resume. CMOS setup. And we have 1.44 meg VGA. Hard disk auto detect. Yes. And advanced. Typematic disabled. Yeah, this keyboard is flaky. WeTech, numeric, unlock, AC, CA, system boot speed high, adapter, ROM shadow disable. Okay. Memory size, that's standard, because It wasn't shadowed when it booted up the first time, but it was shadowed when it booted up the second time. Should be 8064. Wait. Booting. Yeah, expanded memory. Let's see. Device not found. Yeah, I don't have the mouse plugged in. Wondering if this is running in 20 megahertz. Let's see. I'll do user 2. Oops. .7, and then turbo 40. .9. So turbo is correctly hooked up, and the turbo LED is correctly working. So let me show you. So you can see here. It says 40, the turbo LED is lit up, power off, or turbo out, 20 megahertz, turbo LED off. Turbo, not turbo. Turbo, not turbo. Turbo. This monitor is a little flaky. It's got some issues with the raster. I think it just needs a good cleaning of the potentiometers. So it's going to show up. It's building a charge. So let's see. Let me show you the first dual screen program I have here. BC. Waiting. Okay. Why is it so slow? Let's bring it up in a... I know FreeDOS is great, except when you try to run it on vintage computers, on vintage hardware. Yeah, let's try that. And we are turbo. There we go. So, let's see if I can... So this is Borland C++. So if we open a program that I wrote, comments. So this is what's called dual monitor mode. Now, if I, let's see, window, zoom, there we go. So this is where the actual IDE runs, the integrated development environment, and then you've got your actual output. You've got your output on the color screen. So let me show you. I've got a program here that what it does is it bounces some colored dots around the screen. It was something I wrote many years ago, and we'll actually get to demonstrate the turbo button. So we'll do Alt-R, run. It's compiling, blinking, and running. So you can see I've got the IDE over here, and then I've got the program running here. And you're saying, well, yeah, but you can't do two things at once because this is actually not, doing anything. If I hit Control Break, it says User Break, and it says, oh, hey, you broke right here. So we've got our output screen that hasn't been touched. The program is essentially frozen, and the display, its output is frozen there. and then I'm in my IDE here debugging code. So I can say, oh hey, this is a problem. So if I hit step F8, I can step through it, and if I keep hitting F8, you can see it's drawing the dots on the screen over there. Although, I would say there's something amiss. Let's just see here. Run, and let's see, debug. Let's see, 9. That's interesting. I broke out of the program and the variables got corrupted, so now it's not bouncing correctly anymore. So let's do Alt-R and then program reset and Control F9. Run it again. Now if I do Control break again, and then cancel and then hit F8, let's see if it still has the problem. Yeah, it's still corrupted. Must be a bug in my program if it fails under the debugger, but doesn't otherwise. Program reset. Control F9. Boom. So yeah, the whole idea of this program was to be able to have comments bounce around the screen. Okay, so we got the thing figured, we got the driver loaded for the sound card. So let's start stunts just in normal MCGA, VGA mode. Okay, so this is your startup screen for Stunts. You've seen it in color. We'll exit. Yes. Run the setup. Now, watch what happens when we choose Hercules, which I think is kind of interesting for... Now watch this. This blew me away when I saw it. It's actually doing a CGA mode here and then copying that over to the Hercules. So it's got dithered output on the Hercules monitor or Hercules card and the monochrome monitor. It's got color output here on the CGA mode and the VGA card. Now the thing that's kind of funny about this is that this actually, so it has to write to this video card and this video card. And it's not that, they're overlapping in the memory or anything like that. This is CGA color mode, and this is Hercules mode. And you can see that there's a little black line, added raster. And that's because it's taking the 348 vertical lines and then it's making it into 200 by, skipping some of the lines. So I thought this was very interesting. And if we just let it go to the, well, let's see. Now this really shows you the persistence of the phosphor. You can see in monochrome screens why ATMs were burned in. You can see the ghosting on the screen. Oops. I played this game a lot, and believe it or not, the keyboard really is the easiest way to play this game, just the way that the controls are set up. I thought it was incredibly interesting that STUNTS displayed on the Hercules and CGA simultaneously. So let's quit and let me show you this. We have to reboot because Windows doesn't like FreeDOS. Reset switch is your friend. Hi, ma'am. The cool thing is, all this sort of started with me finding an old hard drive that had all my old DOS stuff on it, and I actually had the original drivers for the sound card already on that disk. So let's do setup on this. See, Windows, Video 7, 256 colors. So here we have Windows 3.1 and Hercules Monochrome. That's because the video memory on the VGA card overlaps with the Hercules Monochrome. Because the Hercules video display has memory mapped at B000 to B8000, and when it's in graphics mode it's using that full range, and this is also mapped at B8000. So there's actually two cards in the computer with RAM at the same place. So let's see. Move. The interesting thing about Windows 3.0, 3.1, etc. is you could completely use it without a mouse. It was fully keyboard operable. So let's see. Main, Windows setup, sysedit, control panel, drop it. I don't know what that is. Windows setup. Cannot find Windows setup. Yeah, your control panel today does not have this. So then we'll go to color. You can see emerald fluorescent. Yeah, so fluorescent, hot dog stand, LCD, default screen settings, LCD reverse dark, LCD reverse light, mahogany, monochrome. Here we go. That's much, much better. I would dare say that this is actually usable. Let's see, what does Solitaire look like on a monochrome screen? Okay, get ready for it. Okay. And bouncing cards and Hercules Monochrome graphics. I'm sorry, I never get tired of that. Now watch what happens when I hit the turbo button. Turbo, not turbo. 20 megahertz, 386. Slower than your wristwatch. You'll again, no. I can only look at green for so often, especially with the way it's inverse like this. So, well, you know, that's about it. Almost out of time here, so we have been having some fun, and I've been having some fun. I built a retro computer, and I've got to play with it. Now I get to put the case all together and throw some screws on it, and whenever I want to, I can drag it out of wherever I have it stored, and then hook it up to my workbench here and play with it. But I sure like playing around with the dual monitors. That was always a neat feature. So, well, thanks for watching. Have fun. And catch you later.